All right, so this is Mr. Shagney working through the study guide for our formative, which is on Monday, December 3rd. So I just wanted to go through and make sure that you all understood how to do this. So on the first question, it says figure 2 is a scaled copy of figure M. Identify the point in figure 2 that corresponds to point M in figure 1. So this is point M in figure 1. So which point over here matches that? So we would say point D matches point M, right? Because those are in the same place on both figures. In a scaled copy, you want to be able to identify that those should be the same. So the second question says, figure 2 is a scaled copy of figure 1. Identify the side in figure 2 that corresponds to side EA in figure 1. So EA, I notice that EA runs from this point to this point here. And because EA runs like that, I'm going to look for this figure 2 over here. So that's JK. So line JK corresponds to line EA, line segment EA. And so that's all you have to do for those is find out where which side corresponds or what point corresponds with the other. In question 3, it says figure B is a scaled copy of figure A. What is a scale copy? Scale factor from figure A to figure B. This is figure A. We're going from figure A to figure B. So I'm going to look for a number I know. I know 10 and I know 20. What is the relationship between those numbers? Well, I know that 10 times 2 gives me 20. So is that true for this? 40 times 2 does give me 80. So the scale factor is 2. We can do that by taking 20 divided by 10. That gives us 2, and then I would use that to multiply each side to give me the numbers that appear over here. So with the next question on the next page, it says figure B is a scaled copy of figure A. What is the scaled factor from figure A to figure B? This is now figure A. This is figure B. Notice I'm going to pick one of these numbers, 9 and 3. What is the relationship between 9 and 3? Well, I know that 9 divided by 3 will give me 3, but I can't write that. So the scale factor is actually going to be expressed as a fraction. So 9 times 1/3 gives me 3, because remember, multiplying by a fraction is the same thing as dividing. So 9 divided by 3 gives me 3. That is the same thing. So dividing by 3 and multiplying by 1/3 are the same thing. So the scale factor here is 1/3. Okay, so find the relationship and then place it as a fraction when reducing in size for scale factor. For this problem here, figure A is a scale image of figure B. What is the value of x? You can realize that there's a relationship between these two numbers here, and that relationship is times 2. So that same relationship should exist over here if they're a scaled image. So 9 times 2 is 18, so x equals 18. That is one way to solve the problem. Another way to solve the problem is to know that 6 over 12 is a ratio, and that ratio should be equivalent to the other ratio if they're a scaled factor or if they're scaled copies. So I'm going to put 9 over x. So 6 corresponds to 9, 12 corresponds to the unknown. And then we're going to do 6 times x, which is 6x, and 12 times 9, which is 108. So then I have 6x equals 108. When I have this, I need to isolate x, or I need to get x by itself. In order to do that, currently it's being multiplied by 6, so I want to divide by 6 on both sides. 108 divided by 6. 6 goes into 10 one time, with 4 left over. Bring down 8. 6 into 48 is 8 times, so that also gives me 18. Know that this will always work, because the relationship sometimes between the numbers will not be perfect. Down here on this question, it says figure A is a scale image of figure B. Figure A maps to figure B with a scale factor of 2/7. What is the value of x? Notice that figure A side length should be larger than 12, because if I reduce, right, if I were going this way, the scale factor would be 2/7, but I need to go this way. So scaling down, the scale factor would be 2/7. So what's the scale factor going up? The scale factor going up would be the reciprocal of this. The reciprocal of that is 7 over 2, right? So I need to take 12 times 7 over 2. Remember that when I have fractions like this, I need to put a 1 at the bottom. 12 times 7 is 84. 2 times 1 is 2. Then I have 84 divided by 2. 2 goes into 8 4 times. 2 goes into 4 2 times. My answer is 42. Question 7 says, what happens to a figure when it is scaled by a scale factor that is greater than 1? The figure is enlarged. What happens to a figure when it is scaled by a scale factor that is less than 1? The figure is reduced. This problem says Kendra made a scale copy of the following square. She used a scale factor less than 1. So I can pick any number less than 1, right? So I'm going to pick half, because half is less than 1, right? I can write it as 0.5 or 1/2, and ask myself, what is half of 8? Half of 8 is 4. So any number, right, less than 8, because we know that 8 times 1 equals 8. So any number less than 1 is going to give me an answer smaller than 8. Right, so this side length could be any number that is less than 8. For this problem here, it says rectangle N has an area of 5 square units. James drew a scale version of rectangle N and labeled it rectangle P. What scale factor did James use to go from rectangle N to rectangle P? Well, this is 5 square units. What is the area of this? To find the area, remember it's base times height, so this is 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 9 by 5. The area of that is 45. Now we're comparing areas, remember? So if I'm comparing areas, how many times larger is 45 than 5? Well, I'm going to set up division for that. 5 goes into 45 9 times. Well, that's comparing area. Remember, area is a 2-dimensional value, and a scale factor is a 1-dimensional value. So what I'm going to do is I'm going to put this relationship in a square and ask you what is the square root of this, or what is the side length if this is a given square. If this is the area, so if this is 9, right, then the side length would be 3, right? So I would take 9 and take the square root of that, which is 3, because remember the square root is what number times itself gives you 9, and that is 3, so the scale factor is 3. This problem here says a scale on a blueprint drawing of a house shows that 10 centimeters represent 2 meters. What number of actual meters are represented by 18 centimeters in the blueprint? Well, I have a relationship here. So 10 centimeters over 2 meters. So for every 10 centimeters on a ruler, it actually represents 10 meters in actual distance. And I know that I'm trying to find out how much distance is covered if I go 18 centimeters. So this is unknown, right? So now I've set up 2 ratios that should be equivalent, and I'm going to solve using a proportion. So I'm going to do 10 times x, which gives me 10x, and 18 times 2, which gives me 36. Okay? Now once I get to this stage, currently this is 10 times some number equals 36. I need to get rid of this 10. To get rid of it, I need to divide, because currently it's being multiplied. I need to divide on both sides. So then I have 36 divided by 10. That's top in, bottom out, numerator in, denominator out, whatever strategy you want to use. So 10 goes into 36 3 times. That leaves me with 6. And then because I have no more numbers, I'm going to put a decimal here, and I'm going to bring down a 0. 10 into 6 is 6 times. 10 to the 60, my bad. 10 into 60 is 6 times, so my answer is x equals 3.6, and that's going to be meters, because that's what I was solving for. I was solving for meters because that was my unknown. Okay? This problem is a real doozy because it's an unknown scale, but we're going to change the scale to actually benefit us. So it says Raina is building a 1 to 180 scale model of a real castle. Her model has a rectangular base that is 3 feet wide and 4 feet long. Notice that there are no units on this scale. When there are no units on this scale, we get to determine the units that we want to use. Well, for this one, I want to use this as feet. So let's say 1 foot gives me 180 feet. Okay, so if 1 foot gives me 180 feet, how much would 3 feet give? So that's taking 180 times 3. 3 times 0 is 0. 3 times 8 is 24. 3 times 1 is 3, plus 2 is 5. So this is 540 feet. That's one dimension. What about 4 feet? So then I need to take 180 times 4. 4 times 0 is 0. 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. So that's 720 feet. Now it says, what is the area of the base? Well, these are my two numbers now of the actual base. So I'm going to do 540 times 720. 0, 0, 0, add a 0, 0, 8, 10, add a 0, add 2 zeros, 0, 28, 35, 36, 37, 0, 0, 8, 8, 8, 3. So that is 388,800 feet. Okay, and I know that's a long problem, but you can scale. When you don't know the units, you can use whatever unit works for you. So it says polygon A is a scaled copy, or polygon B is a scaled copy of polygon A. What is the scale factor? So 2.5 to 5. What is that relationship? Well, I can say 5 divided by 2.5. I move the decimal over one time. At the end of every whole number is a decimal. Move that over. 25 into 50, that's twice. Scale factor is 2. Find the missing side length. So if I know the scale factor is 2, if this side is 2.5, 2.5 times 2, 2.5 times 2, 10, 4, 5. Move the decimal point one time. This side is 5. 1.5 times 2. 5 times 2 is 10. 2 times 1 is 2, plus 1 is 3. So this side over here is 3, this side over here is 1. So 3, 5. Determine each measure of the angle marked with a question mark in polygon A. So in this problem, right, remember, if this angle is 82, this angle also has to be 82 because angle measurements do not change. This angle is 53, therefore this angle has to be 53. Okay. The next problem says quadrilateral A has side lengths 6, 9, 9, and 12. Quadrilateral B is a scaled copy of quadrilateral A with its shortest side length of 2. What is the perimeter of quadrilateral B? Well, we have, remember that when I did this problem, I drew a trapezoid, and I said 6, 9, 9, 12, and then I have another trapezoid that's smaller, and its shortest side length is 2. So the relationship between this is being divided by 3, so then I'm going to divide everything by 3, or times it by a third, because it's going to give me the same exact thing either way. And that's going to be 9 divided by 3 is 3, 3, 4. If I add up all these numbers, that will give me the perimeter. So 4 plus 3 is 7, plus 3 is 10, plus 2 is 12. 12 units. Okay. On the next page, it says triangle S and triangle L are scale copies of one another. What is the scale factor from S to L? From S to L, this is 2, this is 4, so this is becoming 2 times larger. So we'd say 4 divided by 2, that gives me 2. What is the scale factor going the opposite way? So if I go from 4 to 2, what's happening? 4 back to 2, it's currently being multiplied by 1/2. That's the scale factor, because you would flip the 2, so this is like 2 over 1, you would flip it, take the reciprocal, which is 1 over 2. It says triangle M is also a scaled copy of S. The scale factor from S to M is 3 over 2. What is the scale factor from M to S? So if this is going one way, the opposite way would be the reciprocal. So you would flip them. This gives me 2/3. S or M to S, that's the scale factor. In this problem, it says a right triangle has an area of 36 square units. If you draw scale copies of this triangle using scale factors in the table, what would the areas of these scale copies be? So if the scale factor is 1, 1 times 1 is 1. So the area would be 36. And this one, you have to take the square factor and you'd have to multiply it by itself. So 2 times 2 is 4. So then I have to take 36 times 4. 36 times 4 off to the side. 6 times 4 is 24. 4 times 3 is 12. Plus 2 is 14. So the area would be 144 here. If I square this area, 3 times 3 is 9. So I need to take 36 times 9. 6 times 9 is 54. 9 times 3 is 27. Plus 3 would give me 32. So that's 324. The area here would be 5 squared. So that's 5 times 5, which is 25. 36 times 25. 6 times 5 is 30. 5 times 3 is 15. Plus 3 is 18. Add a placeholder. 6 times 2 is 12. 3 times 2 is 6. Plus 1 is 7. 0, 10, 9. So 900. Now once we get here, what's a half squared? A half squared means a half times a half, which is really 1 times 1, which is 1, and 2 times 2, which is 4. So that's a fourth, or that's 36 divided by 4, which is 9. And 2/3 squared, I'm going to take 2/3 times 2/3. 2 times 2 gives me 4. 3 times 3 gives me 9. So this is really 4/9 times 36. And now I'm running out of space over here, so 36 times 4 over 9. 36 times 4, we did that earlier, gives me 144 over 9. I took that from this workout that I did over here that you can't see. So 144 divided by 9. 9 goes into 14 one time. 9, 10, 11, 12, 13, 14, 5. And we're going down to 4. 9 into 54 is 6. So this area would be 16. Now these are our measurement problems. We did these problems kind of in class. So we're going to choose a scale that works for us, remember. So I'm going to measure this, right? So this is about 2 centimeters. So 2 centimeters equals 60 miles. So 1 centimeter should equal 30 miles because that's half, right? I'd reduce this by 2, therefore I reduce this by 2. So now I'm going to measure from Amarillo to Oklahoma City in centimeters, right? And this distance is about 9 centimeters. So I'm going to take 30 times 9. That's 0. 9 times 3 is 27. So about how far? It's 270 miles. And then it asked me about driving at constant speed. So if driving at a constant speed of 70 miles per hour, would it be possible to make the trip in 3 hours? Remember, speed equals distance divided by time. So the distance that I'm trying to travel is 270. I'm trying to make the trip in 3 hours. So 270 divided by 3. 3 goes into 27 9 times. And I add a 0. So if I'm driving 70 miles an hour, will I make it? No, I need to drive 90 miles per hour to make the trip in 3 hours. Okay. Here's another scale drawing. So here's a scale drawing where 1 centimeter represents 1 meter. So they tell me what they want me to measure in. So 1 centimeter represents 1 meter. This bottom part is about 10.5 cm. This side part here, for me, is about 5 cm. So how long and how wide is the actual swimming pool? Well, if 1 centimeter represents 1 meter, then this is 10.5 meters by 5 meters. Will a scale drawing where 1 centimeter represents 2 meters be larger or smaller than this drawing? Well, if I take this and say, okay, well, 1 centimeter represents 2 actual meters, remember that I'm trying to get to 10, or like to the bottom. So that's 2, this is 4, 6, 8, 10. Right? So you can see that this line is smaller than this line because I'm really scaling this by half. So this is going to become smaller because I'm scaling by 1/2. Okay, it says make a scale drawing where 1 centimeter represents 2 meters. Obviously, there's not enough space here, so let's do that down here. So this is my scale drawing. It's the bottom. I'm counting by 2s each one, so that's 2, 4, that'd be 5. And then I would go over, I bring this down. Remember that if I wanted, this would be 5 cut in half would be 2.5. This would be 10.5 divided by 2, which is 5. The decimal shoots up like a rocket. 5 comes down. That's 2. 5.25. So side would be 5.25 and 2.5. Next problem says a scale drawing of a rectangular park is 5 inches wide and 7 inches long. The actual park is 280 yards long. What is the area of the actual park? This is a proportion, 5 inches wide over 7 inches long. And then the actual one is 280 yards long. And we're trying to figure out what this is up here first before we find the area. Well, what is the relationship between 7 and 28? Well, I know that's times 4. So really just 0 would be times 40. So this has to be times 40 as well. 5 times 4 is 20, so out of 0, this up here, x equals 200. Now I have my two measurements, 280 and 200. It's asking for area. 200 or 280 times 200. Well, if I look at this problem, what's 28 times 2? 8 times 2 is 16. 2 times 2 is 4, plus 1 is 5, and there's 1, 2, 3 zeros. The answer should be 56,000. This is a pretty big park. The next problem says that the scale on map says that 4 centimeters represents 5 kilometers. We're going to use that in solving the next two problems. So what is the distance on the map in centimeters that represents an actual distance of 4 kilometers? So 4 cms over 5 kms. I don't know how many centimeters that is, but I do know how many kilometers I want, which is 4. This is another proportion problem, so I'm going to do 4 times 4, which is 16. And then I'm going to do 5 times x, which equals 5x. When I get to this point, I need to isolate the x, which means I need to get the x by itself. So I'm going to divide by 5 here and 5 here. 16 divided by 5. 5 goes into 16 3 times. That gives me 15. I'm left with 1. I can write that as 3 1/5. Or I can finish that out, put a decimal and add a 0. 5 goes into 10 twice. 3 1/5 or 3.2 works. So in B, what is the actual number of kilometers that's represented by 5 centimeters on the map? Well, I know that 4 centimeters, again, same thing, same scale, and now I'm putting centimeters at the top instead, and this is unknown. So now I'm going to have 4 times x, which is 4x, equals 25. Now, on this example, I need to get rid of 4. To do that, I need to divide by 4 because it's currently being multiplied. 25 divided by 4 needs to be set up like that. 4 goes into 25 6 times. You're left with 1, so you could write that as 6 1/4. Or you can finish it out. 4 goes into 10 twice. And 4 goes into 25 times. 6 1/4 or 6.25. Either one of them works. So this is kilometers. This one is centimeters. Okay, on the map below, 1/4 inch represents 1 mile. And then there's 3 cities on the map. So I know that 1/4 of an inch equals 1 mile. Another way of writing that is 0.25 equals 1 mile. This question says, if the distance between the real towns of Candler and Canton is 9 miles, so this is 9 miles, this is my unknown, right? Cross multiply. 9 times 1/4. That would give me 9 over 4, which 4 goes into that. 4 goes into 9 2 times, with 1/4 left over. So this answer is 2 1/4 inches. And then if Candler and Otine are 3.5 inches apart, so I'm going to go back to 1/4 inch equals 1 mile. This now is unknown, and now we're saying this is 3.5 inches. Right, so 1/4 x equals 3 1/2. So I'm going to change this, right? This requires a little bit of more extra work. So 3 times 2 is 6, plus 1 is 7 over 2. And then I have 1/4 x equals that. I need to divide by 1/4. And you ask myself how many 1/4 go into 3.5, right? So dividing by this would give me 4 over 1 times 4. So scratch that for a second. So 1/4 into this. I'm going to change this to, I'm going to ask myself how many 1/4 go into 3. Well, I know 1/4 plus 1/4 plus 1/4 plus 1/4 goes into that. That is 4. That's 2. That's 10. That's 8. So it should be 14. So I'm going to do 0.25 into 3.5. X divided by 2.5 divided by 2.5. So 3.5 divided by 2.25. Move it twice. Twice. So now 25 into 350. Well, I know that 25 goes into 35 one time. 0, 1, 0, and 25 goes into 100 14 times. So that problem's a little rough, but especially when you're working with fractions, I need to convert them to decimals. That's just how my mind worked for that problem. So sorry I had a brain fart, but that is our study guide. So you should have everything you need to be successful for Monday's test.